Alright, in this video we are going to do some examples of VSEPR, but if you would like this to also work as practice problems for Lewis structures, I would encourage you to pause the video now actually and go through these two slides here in the video, and in your slides they're actually just one, but work through and try and find the Lewis structures for these now, because I'm not going to be working through the whole process on the Lewis structures. I'm just going to write the Lewis structure up there. So if you want to have these as practice for Lewis structures, go ahead and try to figure out all the Lewis structures now. And then if you would like to also try to work out the VSEPR shapes, you can do that in addition. But I'm just going to go ahead and work through and write down the Lewis structures, and then talk you through finding the VSEPR structures. So we have on this first page methane, which is this. So to find the VSEPR shape, we're going to look at the central atom, which is the carbon, and we're going to see how many things are attached to it, how many bonds, how many things are bonded to it, and then how many lone pairs does it have. So in this case, this would be AB4 is its classification, because it has 4 things bonded to it with no lone pairs. If we go back and check our list here, 4 things attached, all of them being bonds, gives us tetrahedral electron and molecular geometries. The next one here is, try that again. Is sulfur with 6 fluorines attached to it. And just for the sake of time, I'm not going to put the lone pairs on the fluorines, but all the fluorines do have their full octets. But we don't care about their lone pairs for the VSEPR shape. We only care what's happening to that central atom. And so in this case, our classification would be AB6, because we have 6 things attached to the central atom, no lone pairs. And if we look at our guide back here, 6 things attached to the central atom, all of them bonds, no lone pairs. That gives us octahedral electron and molecular geometries. Water. If you work out the Lewis structure for water, it will look something like this. So in this case, we actually do have lone pairs on our central atom, and so this is going to be AB2E2, 2 things bonded, 2 lone pairs. And if we check on our slide back here, 4 things bonded, 2 of them bonds, or sorry, 4 things attached, 4 groups of electrons, 2 of them bonds, 2 of them lone pairs. That gives us a bent molecular geometry, although it still has tetrahedral as its electron geometry. Xenon Tetrafluoride, we actually saw this one already, but I'll go ahead and write out the Lewis structure here. So if you work out the Lewis structure, you should get to this point: 4 fluorines attached to the xenon, and then the xenon having 2 lone pairs. So this is going to be AB4E2. And if we check, because again it has 4 things bonded, 2 lone pairs, 6 things total, 4 of them bonds, 2 of them lone pairs. That gives us square planar molecular geometry. It still has octahedral electron geometry, but this question in particular is asking about molecular geometries. Okay, so moving on then, CO2, we've already seen a few times. Only 2 things attached to our central atom. Both of them are bonds, and so this is going to be AB2. And if you go back and check the the figure there, you'll see that this is linear for both the electron and molecular geometries. CH3Cl, if you work out its Lewis structure, is that. So again, we have lone pairs in the molecule, but we only care about what's happening on this central atom. So this is going to be AB4, just like the methane was. So this is methane here. And so this is going to also be tetrahedral. 4 things attached, all of them bonds. That is going to be tetrahedral in both electron and molecular geometries. In F3, if you work out its Lewis structure, looks like this. And I guess I'll go ahead and put the lone pairs on the fluorines. So we have lone pairs all over the place, but only one of those lone pairs is on our central atom. And so this is going to be AB3E1. And if we check that on our slide back here, 4 things attached, 3 of them bonds, 1 of them a lone pair, gives us trigonal pyramidal as our molecular geometry. And so then the last one here, carbon is going to be central. If you work through the structure, you'll eventually figure out that it is going to be double bonded to the carbon, or the oxygen is going to be double bonded to the carbon. So this is the Lewis structure. So there are 4 bonds to the central atom, but there's only 3 bonding groups, because again, the double bonds count as one group. And so this is going to be AB3, which if we go back and look, that will be trigonal planar. 3 things bonded, or 3 groups of electrons on the central atom, all 3 of them bonds, no lone pairs, trigonal planar is the electron and the molecular geometry. Okay, we're going to call it there for this video, a nice short video. And the next one we're going to talk about polarity and how we can have bonds where the electrons are not being shared equally. See you in the next one.